System of nonlinear equations are system of equations where we don't have lines where they cross in one spot. So before we saw a system of equations where they would just have the point x comma y, and it's that one point. So now what we're going to have, let's look at something we've seen before, a parabola. Say we have a system of equations where we have one parabola and one line. Now our system of equations crosses at 2 points, two different x and y points. Or we could have a parabola, not a very good one there, and it still crosses at 1 point, or it could cross at no points. We could have a parabola where we have another parabola cross at 2 points here. There's a lot of different possibilities. Let's look here. We could have a circle with a parabola that touches down right at that's supposed to touch right there. So it crosses at 3 points. Or that circle could be moved up on our parabola and it could cross at 4 points. We could have an ellipse and a hyperbola, and that crosses at 4 points. So in a system of nonlinear equations, you can have 0 solutions, 1 solution, 2 solutions, 3 solutions, or 4 solutions. You also could have infinite solutions if it was the same equation. For example, if you had the same parabola on top of each other. Okay, so we don't necessarily have to have only one solution for nonlinear equations. Let's take a look at how you would solve a system of nonlinear equations. Let's look at how to solve a system of nonlinear equations using substitution. We really only want to use either substitution or elimination on these types of problems. Using the graphing method would be super imprecise. So let's go ahead and take the equation here and let's solve for y. So y is going to equal 9 minus x. So since this is what y equals, I'm going to plug it in here and I get x squared minus 9 minus x squared equals 27. I want to FOIL this through so we get 81 minus 18x plus x squared equals 27. If we go and solve that, we end up with x squared minus 81 plus 18x plus, nope, that's not right, hold on, undo that, minus x squared equals 27. If I simplify this equation by getting x's by itself, I end up with 18x equals 27 plus 81, which would be 108. And that means that x equals 6. So if we have that x equals 6, we need to find the corresponding y. So here, if y equals 9 minus x, but we know that x equals 6, then that means that y equals 9 minus 6. So y would equal 3. We only found one x value and one y value, and that is okay. Sometimes we won't have multiple solutions, we'll just have the one. Alright, so there is our solution, 6, 3. Or you can write it as a point. Let's look at one more using substitution. This one's a little bit trickier, but what I have here, I'm going to use the red, is I want to take this equation and solve for y. So y is going to be equal to 4 over x. And I could solve for x or y, it doesn't really matter. I thought y would be easier since y doesn't have a constant on it. So then we're going to substitute this in. We get 4x squared plus 4 over x squared equals 20. If I go ahead and square this middle term, I get 16 over x squared equals 20. We get a rational equation, so I'm going to go ahead and multiply through by x squared to get that out of the denominator. So I have 4x to the 4th plus 16 equals 20x squared. Let's bring the 20 over and, well, first of all, let's divide everything by 4. And then subtract that over. So I get x squared minus 5, I said that wrong, x to the 4th minus 5x squared plus 4 equals 0. That's the equation I end up with. So I need to go and solve for all of x's. I have x to the 4th. That means I'm going to have 4 values for x. If we go ahead and factor that, we get x squared minus 1 and x squared minus 4. Which means that I get, factor one more time, x minus 1, x plus 1, x minus 2, x plus 2. So all of my solutions here are x equals 1, x equals negative 1, x equals 2, doesn't look very good, and x equals negative 2. We need to find the corresponding y for every single x. And since we know that y equals 4 over x, I can plug in each of these x's into this equation to figure out the y. So when x equals 1, I get y equals 4 over 1, or the point 1 comma 4. When x equals negative 1, we get y equals 4 divided by negative 1, or the point x is 1, y is negative 4. And then let's follow the process. So when we have here x equals 2, we get y equals 4 over 2. So that's 2, so we have the point 2 comma 2. And then for the last one, when x equals negative 2, we would have y equals 4 over negative 2, which is the point negative 2, negative 2. So these would be our 4 solutions to the system of equations. Let's look at how we would solve a system of equations using elimination. So here I have x squared plus y squared equals 13 and x squared minus y equals 1. You cannot eliminate the terms if they are not the same type of term. So for example, I can't eliminate y squared and y, but you can eliminate the x squareds because they are the same. So what we want to do here is let's multiply this through by negative 1. If we do that, we end up with x squared plus y squared equals 13, and negative x squared plus y equals negative 1. If we add those, we see that the x squareds cancel out and we're left with y squared plus y equals 12. Let's go and subtract the 12 over, and we have a quadratic equation that we can factor. Y minus 3 and y plus 4. So we get two y values. We get that y equals 3 and y equals negative 4. Since those are my two y values, we need to figure out what x equals when y are these values. So we can use any equation to go and find x. We have the easiest one, I would say, would be this one, the x squared minus y equals 1. So let's plug 3 in. We get x squared minus 3 equals 1. So x squared equals 4. If we take the square root of both sides, we get x equals plus or minus 2. Now, let's write those out as points. That means when x is 2, y is 3, or when x is negative 2, y is also 3. So there's 2 points from that solution. Let's go and solve here for the y equals negative 4. So I've got here x squared minus y equals 1. So that means that x squared minus negative 4 is plus 4 equals 1. So x squared equals negative 3. If I take the square root of both sides, your solutions cannot be imaginary. So we don't have imaginary solutions on this right side because you can't take the square root of a negative. So our only two solutions are 2, 3, negative 2, 3.